What? I mean, not every topic that's left. Let's go through all the things that you have coming up on your calendar in this semester. Okay, so on Tuesday is exam 4. So what would that be, 5 days from now, the 21st? And the topics for that, these are all cumulative, so it's everything up through circular motion. And then next week there's no lab. And then after that, let's see, so that would be starting on the 27th, I guess. Lab exam 3. The week of the 27th to the 1st. There's, I think, one more quiz, but I don't remember when it is. There's a quiz somewhere. This same week, the 30th? Okay. And that's the last one listed? Okay. And then the intuition post-test. Will be the lab the week of 2nd, 3rd, 4th. And encourage, this doesn't go on your grade, so I'd encourage you to come to this. I was planning on giving 1 quiz point back. That sounds good, right? I think, well, why don't I look at it and see which, I would be happy to do either one. I was just thinking the quiz might be a bigger chunk at this point because it's so few points per quiz, but all the, what? One of each. That would be nice. I don't know if I'm that nice, but I'll think about it. Do you? Well, we'll soon find out. And then the last thing is the final, exam 5. And there are 2 days you can take that. You want to take it on Monday the 11th in the evening at 6 p.m. That's the next room over this way, 1326. Or you can also take it on Thursday. That's the 14th at 2 p.m. class time in this room. Okay, so that's it. 5 things left. Anybody have any questions about the end of the semester? Does anyone have any questions about homework problems? Yes. Sure, yeah. Okay, let's say this angle is 40 degrees. Let's say this cable is 3 meters long. Let's say the mass of the ball is 5 kilograms. And we want to know first, what's the tension in the cable? And second, what's the speed? The speed of the ball. For a tetherball problem, you take a side view, and it doesn't matter which side the ball is, but I would just always put it on the same side. Just get used to doing it one way or the other. So I'm going to draw it like this. So there's the ball. This angle's 40 degrees. The coordinate system will be here. This length is 3 meters. So the radius that we want is this, and it's equal to 3 times the cosine of 40. The cosine of 40 is 0.766 times 3 is, I can't do that. Can someone calculate that? Point. Yeah. 298. Right? The centripetal acceleration is this way. And the magnitude of the centripetal acceleration is v squared over r. We don't know v, so I'll just leave that as v squared, and we're dividing by 2.298. And then the centripetal acceleration is in the negative x direction. So as a vector, this is negative v squared over 2.298, and then 0 for y. Tetherball problems are always uniform circular motion. That's not true. Like, we've done problems where an object's spinning in a circle from a string this way. That is not uniform circular motion. This tetherball problems are always circular motion because they're spinning this way. And the difference is the orientation of gravity compared to the orientation of the string. Okay. But if it's swinging just around on a string in a circle that's parallel to the ground, it has to be uniform circular motion. There's nothing that can change the speed if we ignore air resistance. And so the acceleration is negative v squared over 2.298, and then 0 for y. Direction is the net force. Yeah, same direction as the total acceleration, so it's in the negative x direction, by the way. That was unrelated to this problem. I just blurted it out. Okay, so now we're going to do a free body diagram. The weight force is like this. So the weight is 5 times 9.81, 49.05. And the tension is parallel to the cable, like that. Where this angle is 40 degrees. And the magnitude of that force, we don't know what it is, so we'll just call it T. So we have to come up with components for this cable force. You can do that by, draw the coordinate system, put the tail of that vector at the origin. This angle is 40 degrees. So what's the angle theta for this vector? Yep, we go from the positive x, 180 minus 40. So theta is 140. And so then that force vector is t times cosine of 140, t times sine of 140. That's negative 0.766 t, positive 0.643 t. And then Newton's second law says negative 0.766 t, positive 0.643 t, plus 0, negative 49.05. Is equal to the mass times the acceleration. The acceleration is negative v squared for 2.2980. I'll use the y equation first. That says 0.643 t minus 49.05 is equal to 0. So it's 49.05 divided by 0.643. 76.28 newtons. So that's the force in that cable. And if that cable isn't strong enough to support a force of 76.28, it would break. And then the x equation says negative 0.766 times t, which we just calculated, so times 76.28, is equal to negative 5 over 2.298 times v squared. The negatives cancel, and so you get 2.298 times 0.766 times 76.28 divided by 5 is equal to v squared. Can someone calculate v for me? 5.1? 5.18? 5 point, okay. Okay, thank you, I will. 5.18 meters per second. Any questions about that one? So those problems are pretty much always the same. I mean, I could say that we know the speed and then you have to calculate something else, or I don't know. Why don't I just not do that? Why don't I just do one like this? Okay, any other homework questions or requests? All right, well, I was thinking today I would just do a uniform circular motion problem and a non-uniform one and just give you time to work on it, and then I'll go through it to make sure you're doing the steps right. So let's do this. So let's say there's a Ferris wheel. Where passengers move with a speed of 2 meters per second. So there's the wheel. Let's say the radius of the wheel is 5 meters. And let's say at 2 separate points, let's do 3 actually. So here's A, B, and C. We'll just go through them one at a time. So first, if the Ferris wheel is moving with a constant speed, what's the force vector applied to a passenger at A by the seat? Okay, so take a few minutes, work together on this, see if you can get through that one, and then after most of you are done, I'll go through it. Okay. So for this one, is this a tetherball problem? No. So we're going to take a view where we can see the circle. The coordinate system is like this. The point we care about is up here. The centripetal acceleration is this direction. The magnitude of the centripetal acceleration is v squared over r. V was 2, right? So 2 squared over 5. So 0.8. And that's in the negative y direction. So this is 0, negative 0.8. What about tangential acceleration? There's none. Yep. So, because the speed is constant. So the total acceleration is just 0, negative 0.8. And then a free body diagram of the passenger. There's a weight force of 100 times 9.81, so 981. And then there's a force vector. We don't know the direction of the force vector, so I'm just going to say we have an unknown x and an unknown y component. So there's fx, there's fy. Newton's second law says fx, fy, you can just lump them into a vector like that, plus 0, negative 981 is equal to 100 times the acceleration of 0, negative 0.8. So the x equation says fx is equal to 0. And the y equation says fy minus 981 is equal to negative 80. So fy is equal to 901. And then all together, the force vector, so this is the force on the passenger by the seat, is equal to 0, 901. And what do you think would be the force on the seat by the passenger? 0, negative 901 because of Newton's third law. And so if you're going to try to calculate, how strong the seat has to be or something for this, you would use Newton's third law that way. Okay, so what do you think about the force? So we have this force that has a total magnitude of 901 newtons. It's uniform circular motion. The speed doesn't change. You think that's going to be basically the same force the whole way around, or you think it's going to change, or you have a feel for that? It will change. It's going to be biggest at the bottom, and the one we just did was the smallest it's going to be. So let's just go through, do it at B, do it at C, and then when we put changes in speed into it, we won't do all three, but we'll. Okay, so for part B, what's the force on the passenger by the seat at the point B? All right, so there's the circle. There's the point. Centripetal acceleration goes this way. The magnitude of the centripetal acceleration is the same as it was before, 2 squared over 5. It's pointing in the negative x direction this time, so centripetal acceleration is negative 0.80. There's still no tangential because it's still uniform circular motion, so the total acceleration is negative 0.80. The free body diagram has the weight and the unknown force vector. Newton's second law says fx, fy plus 0, negative 981 is equal to 100 times the acceleration, negative 0.80. So the x equation says fx is equal to negative 80, and the y equation says fy is equal to positive 981. So the force vector on the passenger by the seat is negative 80, positive 981. Any questions about that one? Okay, well, let's skip the last one and just do non-uniform then. Seems like people feel pretty good about this. Yes? Because the centripetal acceleration was pointing in the negative x direction, and so it's negative here, and then the math comes out that way. Okay, so now let's say that at the top, at point A, it starts to slow down at a rate of 5 meters per second squared. What's the force on the passenger by the seat? Right, so now the speed is going to be changing. It's non-uniform circular motion, so you're going to have to deal with a tangential acceleration. Okay, so this one is non-uniform circular motion. There's the path, the coordinate system. There's the point we're looking at. The centripetal acceleration's this way. Magnitude of that is the same as it was. So the idea is that this just started to slow down, but it hasn't had time to slow down any noticeable amount yet. You know, it's just starting its deceleration. So it still has a speed of 2 meters per second. But now it has the tangential acceleration too. So this is equal to 2 squared over 5. So 0.8 still. That's in the negative y direction. So the centripetal acceleration vector is 0, negative 0.8. And now we have to this time think about the tangential acceleration. It's moving this way. So the velocity is like this. And it's slowing down, so the tangential acceleration has to be opposite the velocity. That's just the same thinking that we've been doing in lab. We know the magnitude of that is 5 meters per second squared. And so it's 5 meters per second squared in the negative x direction, so negative 5, 0. So the total acceleration you get from adding those two pieces, so 0, negative 0.8, plus negative 5, 0. The total acceleration is negative 5, negative 0.8 meters per second squared. And now the free body diagram. There's a downward force of 981, and X and Y components of the force from the seat. So Newton's second law says Fx, Fy plus 0, negative 981 is equal to the mass times the acceleration, negative 5, negative 0.8. So the X equation says Fx is equal to negative 500, and the Y equation says Fy is equal to positive 901. And so the force on the passenger by the seat is negative 500, positive 901 newtons. We still had this vertical 901 force that was required before, and now we also have this negative 500 Newton force that's required to make him slow down at this rate. Any questions about that one? Okay, let's do it down at the bottom. So same question. Okay, wait. So if it's going 5 meters per second, and it's like right when it starts to slow down, and the passenger is at the top, how could it possibly be going 5 meters per second and slowing down at that rate when the passenger's at the bottom? There's 2 passengers. Because it's 2 different passengers. I don't know. That was dumb. Okay, so now calculate. So what's the force on the passenger by the seat at the point C, so at the bottom? Okay, so there's the point we're looking at. Centripetal acceleration is up. The magnitude of the centripetal acceleration is 2 squared over 5, so 0.8. That's in the positive y direction, so the centripetal acceleration vector is 0, positive 0.8. The velocity vector, this is rotating this way. So the velocity vector is like this. It's slowing down, so the tangential acceleration is this way. That's the positive x direction, and the magnitude's 5 meters per second squared. So the tangential acceleration vector is positive 5, 0. So the total acceleration is, you add those 2 up and you get 5, 0.8. And then a free body diagram. The weight is 981. The force from the seat, there's an x component and a y component. And Newton's second law says fx, fy, plus 0, negative 981, equal to the mass times the acceleration. So the x equation says fx is equal to positive 500. And the y equation says fy is equal to 981 plus 80. So what's that, 1061? And so all together, the force on the passenger by the seat is 500, 1061. Any questions on that one? Can we do one more? Another ball problem? We might be able to hear Careless Whisper then. Okay. I think it's good. That's why. Okay, so here's a tetherball problem. Changed up just a little bit from the example I did, the couple of examples I did. So let's say that so this thing's swinging around in a circle. No, I'll do that. Do I want a? Okay, no, let's do the normal one. I just realized that was going to be more complicated than I wanted it to be. Okay, so let's say this angle is 20 degrees. And the mass is 0.5 kilograms. And the rope has a length of 2 meters. And we want to know what's the tension in the cable and the speed of the ball. This is a tetherball problem, so we'll look at it from the side. This angle is 20 degrees. This length is 2. There's the coordinate system. The centripetal acceleration is this way. The magnitude of it is the speed squared over the radius. That radius is 2 times the cosine of 20, which is 1.88, I think. And so v squared over 1.88. It's in the negative x direction. So the vector is negative v squared over 1.88, and then 0 for y. It's uniform circular motion, so there's no tangential. So that's also the total acceleration vector. Now the free body diagram of the ball. We have the weight of 0.5 times 9.81, so 4.905. And the cable force is this way. The angle there is 160 degrees. So it comes out to be 0, negative 4.905, plus negative 0.940 t, positive 0.342 t, is equal to the mass times negative v squared over 1.88, and then 0 for y. The y equation says 0.34, negative 4.905 plus 0.4342 t is equal to 0. So 0.342 t is equal to 4.905. And what do you get for t? 14.43 newtons. And then the x equation says negative 0.940 t is equal to negative 0.5 over 1.88 v squared. And so, and we know what t is. We'll take this, plug it in there. And what do you get for v? 5.11. Ooh, it's like the same as before. Isn't that weird? Didn't we get 5.18 for our last one? That's creepy. Okay. Any questions about that one? Have a good weekend.